Okay, so looking at Part D where we left off, it says, do these data provide convincing evidence of a positive linear relationship between the amount of time and the amount of tip for customers at this Asian buffet? So, I know it says assumed conditions are met, but we're going to go through that whole process. So, the state plan do conclude, we want to perform a test of H naught. We're going to say that beta is 0 versus the alternative hypothesis that beta, or the slope, is greater than 0 or positive, where beta is the slope of the population regression line relating the length of stay x to the tip amount y. We will use alpha equals 0.05. If conditions are met, we will do a test. So let's look at the conditions. First, we will look at the linear requirement. So the scatter plot shows a weak positive linear relationship between the length of stay and the tip amount. The residual plot shows random scatter about the residual line, so there's no pattern there, so we should be good to go. Next, knowing one tip amount shouldn't provide additional information about any other tips. You also need to check the 10% rule. Okay, normal. The normal probability plot looks roughly linear. Again, good to go. Equal standard deviations, the residual plot is fairly equal scatter above and below the line. And then finally, the receipts were randomly selected. So let's go ahead and do a test. In your list of tests, you're going to pick linear regression t-test. In your X list and Y list, you're just choosing list 1 and list 2 with a frequency of 1. We are testing greater than 0 because we're seeing if there's a positive relationship. This is the data that it produces, and so what we are interested in is that p-value, of course. But you do want to make note of your degrees of freedom and your test statistic. You want to write all of that down, of course. But because the p-value of 0.1235 is larger than 0.05, we fail to reject the null hypothesis. We do not have convincing evidence that the parties who stay longer at this Asian buffet leave larger tips. Okay, so if we want to now construct a 95% confidence interval for the slope, here I'm going to go ahead and assume the conditions are met because we already checked them. We don't need to go through that whole process again. So we will now go into the linear regression t interval, again using list 1 and list 2. We're going to do 95% confidence here, and we will calculate. Here's our data here. Again, it tells us our degree of freedom, and it gives us that interval that we can interpret. We are 95% confident, so that's missing there. We're 95% confident that the interval from negative 0.0244 to 0.08468 captures the slope of the population regression line relating money to time spent at a buffet. So once you get past checking the conditions, the tests and the intervals are quite similar. You will interpret them in a similar way as well. Again, you're just going to have different conditions, and of course you're going to calculate your test statistics slightly different and things like that. But the same patterns kind of carry throughout.